everyone, welcome to the channel. So here we are discussing the question maximized array by CodeTON round 6. So the problem states that you are given three non-negative integers n, k and x. Find maximum possible sum of elements in an array consisting of non-negative integers which has n elements, its max value is equal to k and all its elements do not exceed x. If such an array does not exist, output -1. So the max of an array is the smallest non-negative integer that does not belong to array. For instance, we have here 2 to 1. So you see that the smallest number which is not in the array is 0. So 0 does not belong to the array. Next we have 3, 1, 0, 1. So its max value will be 0 is there, 1 is there, 2 is not there. So its max value is 2. Now in third case we have 0, 1, 2, 3. So the max value is the next number which is 4. So the question states that we are given nkx. Here we have three integers. You can name them n, k and x. Now it is a very interesting problem. You know that the max value is k and your number can't exceed x. So first of all, taking some normal cases where you can easily predict what you can output. So let's see the second case. It has n4, k as 7 and x as 5. Now you have the condition that your element can't exceed 5 but your max value is 7. For max value to be 7, you should have 0 to 6 in your array. 0, 1, 2, 3, 4, 5, 6, all these numbers in the array, so that you have the max value as 7. But your number can't exceed 5. Can't exceed 5 means it can't have 6. If it can't have 6, it can't have the max value as 7. So here we can directly output minus. So what we understand from this case is, if our k is greater than not x, it will be x plus 1 because 0 is also included. Remember. So if you take the case, suppose 3 to 1. Now here k is greater than x, but output is there. Why? Because we have 2 here and our k is 2, x is 1. Max value is 2, so we can take 0 and 1. And we can't exceed by 1, so we have 1. Because we can include x and we are starting from 0, so hence we will be putting this condition. If k is greater than x plus 1, then we will output simply -1. Now let's see another simple test case. Another simple test case would be something like 4, 7, 10. If I take 4, 7, 10, now I have n as 4, k as 7 and x as 10. Now if you see in this case, my max value is 7 and x is 10. I don't have any problem with it. Why so? Because okay, I can't exceed 10, but I can have 0 to 6 values. But I need to have 0 to 6 values so that max value is 7. But what my n is? Only 4. So my n is 4. Means when n is less than k, then also you will output what? -1. So we have two cases of -1. Now if these two conditions are not done, let's remove them. If these two conditions are not there, let's pick a valid case. Let the case be 57, 51, 122. So we take 57, 51 and x is 122. Now if you see, you have max value as what? 51. So you can't take a number greater than 51. You can take, but you need to skip 51. You can't exceed 122 and you need to take 0 to 50. It is forceful. You don't have any other option because max value is 51. So what we do, now we can take 57 numbers. Out of 57 numbers, our 51 numbers are gone. What are those 51 numbers? 0 to 50. So what is 57 minus 51? What we are left with? We are left with 6. Now when we are left with 6, so our 6 numbers can be anything, and we have then another 51 numbers as 0 to 50. So when you take sum of 0 to 50, we can exclude 0 as it is a sum. So 1 to 50, if you take sum of n natural numbers, then you have the formula n into n plus 1 by 2. Or you can directly take the sum by running the loop from 0 to I and taking the sum and all. So once you have taken this sum, then you get the answer from here. So what will be the answer? 50 into 51 by 2, which would be 25 into 51, which gives 1275. So we get 1275 as the output. Now the remaining 6 numbers. We need to maximize the sum. The numbers can't exceed x, but it can be x. So I will take the remaining numbers as 122. So here I take 122 into 6 and add this with 1275. Now 122 into 6. What is 122 into 6? It is 732. And if you add 732 to 1275, so it gives us 2007, which is our answer. So this is the approach. Now one thing is tricky in that, what if our k is equal to x? If our k is equal to x, then we can't take here x to multiply with the remaining numbers. So what we will take? K minus 1 or x minus 1. So if my k is equal to x, like here 3, so my x would be, x minus 1 would be 2, and I would be multiplying 2 with the remaining numbers. So it will be, we need to take 0, 1, 2. So first I take 0 plus 1 plus 2, which is 3. So I directly take 3 here. Now plus, how many numbers are remaining? 2. 2 into 2. So I get 4 plus 3, which output 7. So simply for this, the formula is, let me first remove this. So the formula is, here n is our k minus 1. K minus 1 into k by 2. Let me write it clearly. So k minus 1, because here 51 was there, till 50 we are taking the sum. So this is our sum till 50, and then plus x into what? The remaining numbers, which are n minus k. As we did here, 57 minus 51. Like this we do n minus k. So we get the output like this. And if k is equal to x, then here instead of x, we would be writing x minus 1. And don't forget to put the conditions of minus 1, which we discussed earlier. So I hope you all understand the solution. Thanks for watching.